Have you ever really thought about what goes into fixing a tooth? We kind of take it for granted, but the materials dentists use in our mouths are these tiny, incredible marvels of science. Today, we're going to pull back the curtain and explore the amazing engineering that goes into building a smile that not only looks great, but also lasts. So, what's the secret sauce here? I mean, is it just about being super strong? Or is there a little more to it? Well, the truth is, the perfect material has to pass a whole series of pretty brutal tests inside one of the toughest environments in the entire human body, your mouth. Okay, let's dive right in and figure this out. So to get to the bottom of this, we're going to look at the key challenges every single dental material has to face. We'll start with the problem of getting a perfect fit. Then we'll talk about how the material actually feels. After that, the science behind making it look real, and finally, how it holds up over time. And you'll see it's all one big balancing act. Let's get to it. First up, let's talk about fit. And honestly, this might just be the most important challenge of all, because if a filling or a crown doesn't fit absolutely perfectly from the get-go, well, it's pretty much doomed to fail. Now, here's where things get really interesting. When a lot of these dental materials harden or set, they go through a chemical reaction. A great way to think about it is like a bunch of tiny molecules suddenly linking arms and pulling in super close together. This process is called polymerization, and it almost always causes the material to shrink just a little bit, which can create a tiny, tiny gap between the filling and your tooth. So scientists have a fancy term for this, of course. They call it dimensional stability. It's basically just a measure of how well a material holds its shape after it's already hardened. A material with high dimensional stability isn't going to shrink or expand or warp over time, even from things like absorbing water. So the takeaway is this: a perfect fit today has to stay a perfect fit tomorrow. All right, time for a quick little check-in to see if you're with me. What is the biggest problem, the main consequence, if a material shrinks too much after it's set? Have a think and lock in your answer. And the answer is B. It creates a poor fit. It leaves that little gap we talked about. And you know what? That tiny gap is a huge problem. It's like an open invitation for bacteria to sneak in, which can lead to more decay and eventually the whole filling failing. When it comes down to it, the fit is everything. Okay, let's move on to our next challenge. Because it's not just about how it fits, it's also about how it feels. I mean, nobody wants to feel like they have a mouthful of heavy metal, right? This brings us to a property called density. So density is basically just how much stuff is packed into a certain amount of space. And when you're designing something like, say, a full upper denture, this becomes incredibly important. Think about it. A heavy, high-density material is just going to be pulled down by gravity all day long, making it feel awful and making it hard to keep in place. That's why a lighter, low-density material is usually the way to go for comfort and for stability. Okay, quiz time again. So based on what we just talked about, what's the number one reason a dentist would pick a low-density material for an upper denture? Think about it for a second. And of course, the answer is C. It's all about fighting gravity. A lighter denture is way more comfortable and has a much, much better chance of staying right where it's supposed to. We've covered fit, and we've covered feel. Now for what a lot of people would say is the toughest requirement of all: the appearance. A restoration has to look so real that it just blends in seamlessly with all the natural teeth around it. Getting the color just right isn't as easy as picking white from a paint bucket. As you can see here, a tooth's color is this really complex mix of different visual properties. It is a true science that both dentists and material scientists have to absolutely master. To measure colors scientifically, experts break it down into 3 dimensions. First, you've got hue, which is the base color we see, like, is it a little bit reddish or a little bit yellowish? Then you've got chroma. That's how intense the color is. So is it a pale yellow or really vibrant yellow? And finally, there's brightness, which is just what it sounds like. How light or dark is it? Okay, let's test that out. Which one of those 3 terms describes how intense or saturated a color is? What do you think? That's right, it's chroma. And getting all 3 of those, hue, chroma, and brightness, perfect, is the real key to creating a restoration that just disappears into your smile. Okay, so we've got a material that fits perfectly, feels light, and looks totally natural. But is it a survivor? Can it handle the daily chemical attack from everything from your morning cup of coffee to that acidic salad dressing on your lunch? This brings us to two really important chemical properties: solubility and erosion. Think of them as twin threats. Solubility is basically how much a material dissolves in a liquid, like your saliva. Erosion is like a double whammy. It's that chemical dissolving action combined with some gentle physical action, like chewing, that wears the material away even faster. And let me tell you, your mouth is an unbelievably tough place for a material to live. The pH level can swing like crazy, from super acidic, like a 2 after a soda, all the way to highly alkaline, like a 12 from certain toothpastes. So here's the kicker. A material that's perfectly stable in a neutral mouth might just break down super fast in acidic conditions. And that's exactly why something might work great for one person but fail completely for someone else with a different diet.
Last question for you. Which of these terms specifically describes how well a material can resist dissolving? Take a moment, think it through.
The correct answer is B, solubility. A material with low solubility is one that's really built to last in that wet and wild environment that is your mouth. So we've walked through all the major hurdles, getting that perfect fit, the right feel, a natural look, and of course, the chemical toughness to last. And this brings us to the big takeaway. The grand conclusion? It's all one giant balancing act. The truth is, there's no single perfect dental material that does it all. It is always, always a compromise. A material that looks absolutely stunning might not be strong enough for a molar in the back, and a super strong material might be way too dense and heavy for something like an upper denture. The real art and science of dentistry is all about choosing the material that strikes the absolute best balance for each person and each unique situation. You know, when you stop and think about it, from simple metals to the advanced ceramics and composites we have today, these dental materials are true engineering marvels that we carry around with us every single day. And it really makes you wonder, as science keeps pushing forward, what will that next generation of perfect materials even look like? What will they be able to do?